welcome back to differential calculus class. So we are still on partial derivatives. So in this class, I'll be talking about product rule. So here, so let's assume we have a product function z equals u of x and y. Then we have v that is multiplied by v of x and y. How do you find the partial derivatives of this? So the partial derivative of this, mind you, we can use z, that is z to x, which is equivalent to the z dx. Okay, if you have watched my video on notation, okay, so it's equivalent. So it's equal to u, this function you have here, okay, u of x, y. That is the complex one, but I'm going to use just u. So we can use it, u, okay, then we have dv, that is function here, dx, plus v du dx. So this is what the rule says. Okay, now for the partial derivative of, this is for the partial derivative of z with respect to x. What are the partial derivative of z with respect to y? That will become u dv dy. You can see, just change the x here to the y to show that we are doing with respect to y. Then plus v du dy. Can you see that? It's very simple. So now let's take a look at an example. So let's say we have given z equals to, let's say we have 3x plus 5y, then multiply by 2x plus 6y and we are asked to find the partial derivative. So we have to find the partial derivative. Let's say dz dx and dz dy. So here is the solution. So we have the function. You can see here we can identify this, the whole of this from here represent our u, and from here to here represent our v here. Okay. Now, if we apply this rule, that is z x, okay, you know, is equals to u dv over dx plus v du dx. So here, our u here is equals to 3x plus 5y, okay. Then our v is equals to 2x plus 6y, okay. Therefore, we can find the u dx is equals to du dx. Mind you, this is an additive function, so the focus will be on the function that has x. So the u dx here is equals to 3, okay. Likewise, the v dx here is equal to 2. Having gotten that, so we can now go back here and substitute into this. So in other words, we can have that our zx, which is equivalent to the z dx, is equals to u. What is our u? Our u is 3x plus 5y. dv dx. What is dv dx? This z, we have to Then plus we have v. What's our v? Our v is this 2x plus 6y. Then we have du dx. What du dx? Du dx is 3. Then we are good to go. We open the bracket. We have 2 times 3x, that is 6x, plus 2 times 5y, that is 10y. Then plus 3 times 2x, that is 6x, plus 3 times 6y, that is 18y. Then we can simplify further. So we have 6x here, we have 6x here. That is 12x. Okay. Then we have 10y here, then we have 18y here. So that is plus 28y. This is the final answer for the partial derivative of z with respect to x. What of the partial derivative of z with respect to y? Let's do that here. So z with respect to y equals to u dv dy, then plus v du dy. So here we already know our u, that our u is equivalent to this. So also here we can also simplify further and say our du dy, du dy here is equals to 5. Likewise, du dv dy here is equals to 6. So we know our u. Our u here is 3x plus 5y. Then dv dy. What's dv dy? dv dy is equal to 6. Then plus v. Our v is 2x plus 6y. Then du dy. What's du dy? du dy is 5. So in other words, we open the bracket, 6 times 3x, that is 18x. Then plus 6 times 5y, that is 30y. Then we have plus 5 times 2x. 5 times 2x, that is 10x. Then we have plus 5 times 6y, that is 30y. So we can collect the like terms. So we have 18x, we have plus 10x. We collect the like terms. So 18x plus 10x, here we have 28x. Or let me just bring it together so that you get it right. We have 18x. Then you take this to this side, we have plus 10x. Then you have plus 30y plus 30y. So in other words, we have 28x. Then plus 30y plus 30y, we have plus 60y. This is the final answer for this. Okay, so can you also try this? Can you try this? So let me explain this. Okay, good morning. Can you try this? Let's say we have z equal to 2x plus y. Then we have x plus 2y. So can you find the partial derivatives applying product rule? Drop your answer in the comment section. Thank you.